fifth graders, welcome to lesson 6-1, Patterns for Dividing Decimals. Our I can statement is, I can use mental math and place value patterns to divide a decimal by a power of 10. Please write your lesson title and I can statement in your math journal, and go ahead and move on to the next slide when you are ready. Our problem today says an object is 279 4/10 centimeters wide. If you divide the object into 10 equal parts, how wide will each part be? Solve this problem any way you choose. Down below in the little bubble, it says, how can you use structure and the relationship between multiplication and division to help you? Well, the first thing we're going to do with this problem is use cubes. Get my pen working here. So cube stands for circle our important numbers. So 279 4/10, and we're dividing that into 10 equal parts. This is the first time we're looking at dividing a decimal instead of whole number. Okay, we need to underline our question. How wide will each part be? Okay, I want to box the part that says if we divide the object into equal parts, and I'm also going to box centimeters because that's what we're working in. So we need to evaluate this and visualize it like we were doing this problem ourselves. So we have an object that's 279 4/10 centimeters. You can pretend like this is anything it could that we want to divide into 10 equal parts. So now I want you to think about what you know about multiplication and division and solve this problem any way you choose. Once you've tried it on your own, please press play and I'll go through and show you a strategy and we'll talk about it. Okay, so I'm going to write out our division problem of 279 4/10 divided by 10. Now, today it's saying it's looking at maybe using a mental math strategy to do this. You could have lined it up using standard algorithm to work through this. It's really, our learning goal is using patterns to solve it. So I'm going to talk about it, how I think about it using multiplication and division, how I kind of think about a pattern in this problem without lining it up like standard algorithm. We will get to that soon, and I might even show you that if I have time. All right, so I'm going to think about what I know about multiplication and division, and it's an inverse operation. It's kind of like it's the opposite of each other. So I want to think about when I'm multiplying 279 4/10 times 10, I want to think about how this works because it's going to give me a clue about how I can use this pattern to actually divide this problem. So when I do this problem, I know I have a 0 here. And so that means I can, without lining it up and doing multiplication, I can move my decimal point to answer this problem. So when I'm multiplying this number times 10, I am actually going to move that decimal point and place value to this area. So I'm going to move this one place to the right. Okay. I'm just going to use a big capital R to signify right. When I do that, I know that I would get the whole number answer of 2,794. Now that's not what this question is asking me, but I'm knowing when I multiply, I'm moving my decimal place to the right, that one place value that 0 is showing me in 10. Now, if I want to do this using kind of the same thinking, if I divide, that's the opposite or inverse operation of multiplying. So if I divide this, I'm going to move this one place value to the left. And I would get this answer, 27 94 hundredths centimeters. Okay. Now let me show you a little bit about how this works if we wanted to set it up and do it as a standard algorithm problem, which some of you might have done since we've been working with that lately. My divisor is going to be 10. The original number is 279 4/10. So this is like a second way that you could have done this, all right? I'm going to follow the steps of division. And I am going to go ahead and I'm going to put my decimal point right up here where I know it needs to stay in my answer, okay? So I know that 10 goes into 2 0 times. I'm going to do all of the steps. Some of you might put an X there. Okay, I'm going to bring down that 7. I know that 20 goes into 27 2 times. Going to subtract and bring down. I know that 10 is going to go into 79 7 times. I'm going to kind of forget about that decimal point. I'm not going to put it into my work here. I'm going to bring this down. I know, oh, that should be a 4, not a 9. So I'm working with 94 here. I know 10 is going to go into 94 9 times. I'm running out of room. And I subtract. Okay, I'm going to go here. I'm not going to do a remainder 4. I'm going to go ahead and put a 0 here, annex a 0. Okay, this does not change the value of 279 and 4/10. 279 and 40/100 means exactly the same value as 279 and 4/10 is equal to 279 and 40/100. Okay, that's a big decimal point there. All right, so I'm going to bring down this other 0, and I know that's going to go in 4 times. So whether you thought about this using a pattern and thinking about how we can multiply by 10 and move our 0, we can also multiply and or divide by 10 and move the 0, except instead of moving it place values to the right, you move place value to the left. So let's go ahead and take a look at how some other students work this out. And we'll do more with this strategy for dividing decimals in coming lessons. Okay, Tamara's work, she did something similar to the first way I showed you. She thought about multiplication and how multiplying by 10 works and how we move that decimal point. So she kind of found the same thing here that I did. She knew that when she multiplied by 10, she's going to move her decimal point to the right. So from there, she realized that when she divides by 10, she's going to move that decimal place to the left. And in this case, she knew just one place value because she's working with 10. If she was working with 100, it would go 2 places to the left. So the decimal point moves 1 place to the left when you divide by 10. That's the important idea that you want to get from this. Let's go ahead and look at the next. Max's work, he actually, the answer he got was if he had multiplied this by 10. So he was a little confused kind of on how that operation should have worked. So when you're dividing by 10, we would not get this whole number. We would get 27 and 94 hundredths centimeters. At this point, you need to write the secret word at the top of your paper. The secret word for today's lesson is the word pizza. Please write pizza at the top of your math paper next to the lesson title and your name. Now at this time, please summarize your thinking about how you solved this problem. If you solved it using standard algorithm, please write that down and explain. If you solved it looking at patterns of multiplication and division when we are working with 10 or 100, please write down that so that you can share it with your partner. Thanks. Bye.